It's now visible.
Good, sir.
Kelistidya, I'm audible now.
Hi, sir. Kelistide, sir.
Okay.
Audible, visible. Okay.
Thank you. Thank you. Thanks. So, good morning, all of you again. So, I'm back to you to discuss for another 75 minutes. There is somebody who has kept audio unmuted. Hello? Dear participants, please keep your audio muted unless you want to raise some questions or any points for clarification. Then you can keep it unmuted. Otherwise, please keep it in muted because your background noise is audible. Thank you. So let me continue talking about what is actual learning and how is that and so on. Imagine that here are now given you some classes of objects, images. We have one group of oranges. I mean, unlike the previous question here, we wanted to identify the groups. Here, groups themselves are given. I mean, oranges. These are the two types of learning we are talking about. So here, not only the samples are grouped, the labels of the groups are also given. But in earlier, only samples were given, only examples were given, and nothing else given. So that is with no added information. But here we have some additional information. So I say these are the oranges. I say these are the elephants. I say these are the pictures of human being. And these are the Mysore pox. These are the capsicum, right? I just allow you to understand how many groups? 5 groups. What are those groups? Orange, elephant, men, capsicum, Mysore pox. And you understood, you have seen the examples of each group. Having seen the examples of each group, you must have come out with some knowledge of discriminating them. Please let me underline. Discriminating them. I mean, in artificial intelligence, what really matters is ability to discriminate objects from other objects, right? So that's what it's called. Now I give you one more picture. I'll give you one more picture, Abdul Kalam sir's picture. Now my question is it a member of orange? Is it a member of elephants? Is it a member of men class? Where does it go is the question. Amongst these 5 groups, where does this go? Then you would say that it goes to class 3, men. Why? How? Right? Why? Why should it go there? How do you answer that? It should go to men only. If this understanding, if this mental ability in classifying or in making it a member of a men group, you have used some mathematics unknowingly. That is the beauty of mathematics. Look, unknowingly, I just have worked with some mathematical operations indirectly, so that I become capable of placing this Abdul Kalam sir's image as a member of the group 3 men, but not member of oranges, not member of elephant, not member of Mysore pak and capsicum. Why? On what basis? There was some mathematics. If that mathematics could be understood and programmed, if that mathematics could be understood thoroughly, and if the same understanding can be programmed, put in a form of a program, and computer goes through the program, then computer automatically becomes capable of classifying a new image as a member of already known classes. That is what is called one type of learning. In this learning, in addition to group, in addition to the categories, 5 categories, the category samples were given and category labels are also given. This is added information. Like students are taught by a teacher. One type of learning is a self-study. No teacher is teaching a student. He himself understands and then reads again, finally comes out with an understanding. Another one is, no, everything is clearly given by a teacher. Then students will just simply understand that. That is another learning. So these are the 2 different types of learning. One is analogous to self-study. We call it as unsupervised. This is on your own, but there are 3 categories, but nothing explicitly given. Whereas this one is explicitly given, and then you become so capable of classifying an unknown sample as member of known categories. This is what is called taught by a teacher, supervised learning, supervised by a teacher. These are the two types of learning. One is unsupervised, the other one is supervised. Supervised is basically called classification problem, right? Classification. This is an example for learning. Look at, I want you to learn these pictures. There are about 4 plus 4 plus 3 11 pictures are there. So I want you to learn these pictures. How do you learn? Probably some of you would learn that there are males, there are females, and fruits. Three classes. Male group, female group, and fruits. And some of you may learn that there are politicians, there are actors, and there are fruits. This is another three. Look at here. Learning is not that objective. Learning is more subjective. Learning is a more subjective. Earlier education system was more objective system, teacher oriented. This is what you have got to learn, whether you like it or not. But now that learning has become subjective in NEP, student centric education. The same topic, student may learn in different style based on his requirement. Okay, here one is classifying these 11 into 3 groups where 2 apples would go together and one set would go together as males, another one would go together as female, and one more would go together as fruits. Look at, these are the 3 categories. Because tomorrow I may like to group the photos either into men class or into female class or into fruit class. That's my interest. Then I learn the group in this way. But on the other hand, somebody may be interested in saying, no, I'm not interested in gender information. I don't want to say whether that photo is a male photo or female photo, but I want to say whether photo is a politician photo or actor photo. Then probably this may be the best way of learning for the second purpose. Again, a 3 group only, but the first group has got all politicians, irrespective of the gender. The second group has got all film industry people, irrespective of the gender. Third one, only fruits, right? This is on somebody's interest, right? I mean, before you learn the data, before you insist upon artificial intelligence based solution to learn the scenario, you have got to understand the purpose of learning. That's more important. I mean, that's what the NEP is now canvassing. A student will join for a graduation. What is his purpose? Why does he join graduation program? He must have some interest, some intention. What is that? Based on that, his interest and his purpose, his really, requirement, let him choose courses of his choice. That's what is called choice-based education, student-centric education, right? So this is another way of learning. These 11 sample, look at, even for 11 sample, there are different types of learning, right? Different ways of learning. Somebody may be interested in, no, sir, I am not only interested in, classifying them as politicians and actors and fruits, but I want to know whether he's a male politician or a female politician, right? Even in film industry, I want to know whether they are actors or actress, male or female, right? So then I would recommend to learn in the following 5 groups. The first one will be male politicians. Second one, male actors, and female politicians, female actress, and then fruits. These are the 5 groups. This is another way of learning. I learned them into 5 groups. And now, given is a photography, I may classify. So after learning into 5 groups, after learning into 5 groups, my interest is to know where does this bottommost picture would go. Look at the left side, there is a white and black picture, the bottommost picture. Where does it go? Obviously not into the first group of male politicians, not into the second group of male actors, and not into the fruit. But I have a dilemma. Because let's assume that I have not seen the photos of this Indira Gandhi, who happened to be the great lady politician of India, right? Very known for his dareness, a very great lady of India. But looking at her beauty, I have some dilemma. Probably she looks to be an actress. So it may belong to this. Because I know that she's Indira Gandhi, she was in politics. Then I say that she is a female politician. Then what is the probability, what is the weightage, and based on the weightage you are going to categorize, right? Look at this is what is called learning to classify. Unsupervised initially, look at this is unsupervised. I have given you only samples, no data, additional data. You made it supervised into groups, and now you are classifying it. I mean, unsupervised becomes supervised. Self-study, I join the college, become supervised study, and then appear for the examination. This is how the computers have got to be trained. I'm just relating computer training or machine learning to actual real life human learning, right? Okay. So unsupervised learning to supervised. So this is one working model which we have seen, especially in Germany, way back almost 10 years back itself. It was successfully deployed. So you can imagine in Mysore city, especially in Mansa Gangotri Lake campus, there is a gate, big entrance gate. But security guards are maintaining that. Security guards are standing there and watching myself driving my car into the campus. And sometimes, if a security guard is a new guard, a new person, he stops me and asks me a couple of questions. That too, when I try to drive my car into the campus after dinner, because I go to my research laboratory, my scholars are working all night. I generally go to my once in a while, at least once in fortnight, I make a visit to my laboratory after dinner. When I go there after 9 o'clock, obviously, if security is already familiar with me, then he doesn't. He just opens the gate and sends me inside because he knows my car and he looks at me. He's familiar with me. But sometimes a new security guard come on that day. He stops me and asks me a couple of questions. Who are you? Where do you want to go? Can you show me your ID and so on, right? So instead of that, can we not think of deploying a camera over there? Let camera sense and understand that, oh, this is Guru, sir, and Guru is driving. It's not that somebody is driving his car, because car must have been theft. So it's not only that car is belonging to one of the faculty of the campus, and it's also that faculty himself is driving. Recognize the face, recognize the face, and then automatically gate should be open. I should never notice that my entry is being monitored, my entry is being surveillance, right? So without bringing it to the notice of the person, if the system works, then I say that it's a more effective and protective system. I don't get disturbed because I'm thinking on some what to discuss with the student while driving. So if I am disturbed, then probably I may get deviated. Look at that I shouldn't have any disturbance for that matter. So this is, I mean, the moment the car steps into the sensors on the road, then automatically the camera will take up a picture, and number plate area will be cropped out. Okay, I will show you a video later. Number plate area will be cropped out, and numbers gets recognized, and recognized number gets matched against the stored numbers. And those, if it gets matched against one of the stored number, then car is identified to be an authenticated car. Is not that the number should decide, it's also the shape of the car. It's also in addition to my Innova car number, that number, because somebody must have taken away my car number and plugged into his car. No, that should not happen. So car shape or model, make, everything has got to be stored in the computer memory. And as and when my car goes over there, recognize the number, retrieve that, and it says that it is Innova, golden color. Then the system has to see whether it is Innova or not. If Innova, is it a golden color Innova or not? If everything matches, then it is authenticated. Then who is the driver? Take the picture of the driver face automatically, quickly. That's more important. Real-time applications. All these process should not take one day. All these process should not even take 5 minutes, because within 5 minutes there will be a queue of cars. That should not happen. All things should happen in real time, right? So that is what is challenging. That is what is called computer automation, especially moving towards smart computing technology with the support of artificial intelligence. So this is another application of artificial intelligence in automation of tile inspection process. Every manufacturing company has a quality assurance cell. Before delivering the product being manufactured, that product has got to be verified for its goodness. So that is what is called quality assurance. And the way in which we, the university, conduct examination before we release the students, we look at their qualities. And if anybody is not found to be good, we block him and give him another examination, right? So similarly here, before tiles are released for operational purpose, the tiles have got to be inspected. That inspection process has been automated. So the moment tiles have been manufactured, they are placed above a conveyor belt, and conveyor belt will carry the tiles from one end to the other end. While moving the tile from this end to the other end, beneath there will be sequence of cameras. Each camera would capture the pictures of the tile in different orientation and views, and all images captured are subjected for verification, matching against the stored reference pictures of the tile. And if there is exact matching, then tile will be identified to be good, acceptable, otherwise it gets rejected. Look at this inspection speed, it was about 40 tiles per minute during 10 years back I'm talking about. Now looking at the ability of the computing system, the speed with which the computer can process the data today, probably that 40 tiles per minute would have been expanded up to or enhanced up to 400 tiles per minute. That is what is the productivity, the ability of a computing technology for a betterment of quality assurance in this organization, for example. Look at in forensic science, forensic science. So this technology is being well exploited, well adopted. So I doubt if you can read anything in this picture, which is obliterated. I mean, somebody has written something original and then striked out fully. What is that? I, being an image processing man, I can get the data hidden inside. I can extract the data hidden inside. I can discover it. I mean, look, I do some operations, mathematical operations. If I can program it, then my computer can do it. Then I got the data back. So there was originally 10, 0, 0, 0, 0 were written. So now, then finally above that, I mean, look at, initially it was a white sheet. Above that, 10,000 is written. That's another layer. Above that layer, using pencil, the scratch is made. That is the third layer. The question is to separate these layers separately, right? So if I can erase the top layer, the 10,000 is visible. If I can erase the middle layer, then white sheet is completely visible. That is what is image processing today. So you can enhance the appearance of it so that next subsequent task of classification becomes simple and effective. Look at, the picture is not so good. It is full of, what do you call it as unclear. I mean, blurred, you say, because of mist, because of snow. In case if you happen to be in Himalayan mountains during the month of January beginning or December, probably, even if you click a picture is not so clear. You will see only what, mist and snow. But you take a picture where you are present. However, you are close to the camera, but still your face is not clearly visible. But see that you click a picture with your presence and bring it to my laboratory, give it to me. I will get you the picture enhanced so that you are visible clearly. So look at, here is the processing. I have done some mathematical operations on images. What operations I have done? Some matrix operations on this, because image is a matrix for me. Two-dimensional arrangement of data element. I have done some matrix operation on this. If that could be programmed, I say that computer enhances the picture, right? Computer does it. Look at here. This outdoor landscape image, not so clear. I could enhance it. Very interesting picture. No, very beautiful scene which has been captured, right? Aerial image, right? So look at, you cannot count the number of faces, the people present in this picture, because only one or two faces are to some extent visible and rest of them are not visible. And you cannot even notice what is the of these people, right? Then if I do certain operations on it, look at, now you can count the number of faces. Not only that, today the system has been trying to that extent of what, I mean, tools are available to that extent of what, identify the area of the faces and recognize who are those. It's not that you can say that there are 7 persons. You can also list out the names of those 7 persons automatically. So that is what is called machine learning and artificial intelligence. So probably your organization must have deployed, biometric based attendance taking system where you are going to provide your fingerprints and so on and so forth. One in the beginning, early in the morning, another time in the afternoon, yet another time while exiting from your colleges. So probably that's what is biometric. Um, so instead of biometric in the classroom, we cannot expect students to give their thumb in person. Instead, you can set up a camera above the board, blackboard, on two different corners, top corners of the blackboard. You keep the cameras and let the camera continuously run and mark the attendance automatically on an Excel sheet in a computer. You need not carry the attendance book and take this, attendance by calling them one by one, or you can hand over the attendance book for the students to sign in against their name. Nothing doing. You can initiate. I have an attendance system where there are two cameras. The camera will continuously monitor.
Now I have some queries. After my question, the public can ask.
I'm sorry.
I have very simple questions here.
Hello, participants.
Objectives of periods. Okay, general
Kumar
objectives.
Swami.
Do you see that
Shivakumara Swami,
on the objectives of input
Please mute your mic.
in the
Vasanta.
Okay. Ile
Hello,
very objectives
Shivakumar Swami.
objectives gain ಆ ಎಲ್ಲ periods objectivesಗಳು fulfill ಆಗಿದಾವ ನಿಮ್ಮ study
Who is that? Shivakumar Swami? Is it from Academics of College?
government objectives
Anybody knows?
No, sir.
Shiv Kumar, please mute the speaker.
ಎಲ್ಲರಿಗೂ objectives
Yes, Guru sir, please go ahead. Sorry.
See, you can keep the two cameras on, and the advantage of that is that the system doesn't simply record the physical attendance of a student attending your lecture. While capturing the videos, that video need not be displayed in front of you. You can make the system so intelligent in identifying people, looking at their facial expressions. You being a teacher while teaching your students, don't you think that, oh, this guy is really finding my lecture to be difficult to understand? Then you will interact with him, right? Looking at his facial expression. Or sometimes you see somebody, with a closed eyes and, he doesn't listen to you at all, he started sleeping. And somebody are good, they keep their camera on, eyes on, but CPU is completely off. They are simply looking at you, but they don't understand anything. That also you can guess it, right? If we can do so, why not my computer? Then capture the signals of videos, and looking at the video signal, I want the computer to identify the faces in the scenery, and looking at the facial expressions of the boy or a girl, the system has to classify the students into the following 4 categories. For example, one class of students who are very alert, keeping eyes on and CPU and brain on, listening to your lecture, understanding. Another class of students who have closed both CPU and camera and started sleeping permanently. Yet another class is they are very dangerous people, looking at you as if they are listening, but nothing is getting into their mind. Third class of people. Yet another class of people, they keep their camera off but CPU on. They are simply listening to you unknowingly, right? These are the 4 classes of people. Then your system can, by the end of your lecture, system can tell you, these are the list of people who are really alert in your lecture hall. These are the list of people who started sleeping after 10 minutes of your lecture, opened their eyes only 5 minutes before your lecture. And for every individual who started sleeping, a sleeping time, dwell time can also be calculated. Can we think of that, right? That is where we find AI applications. So because I'm sure that NEP is towards that and making most of the tasks, most of the activities of a teacher and also students to be automated, and working models will be deployed in the educational environment. So that's some examples to quote, to make you all alert and appreciating the importance of artificial intelligence, especially in life sciences. We have many agricultural science. Dear friends, still we have to make up our mind to take up the technology for agricultural domain. Unless we take up this technology for agricultural domain, it's indeed impossible to make India developed India. So we are going to see that the technology should be well exploited in food industry. Is very important. Food industry. I still remember. Probably I will have a slide related to that. It happened in 2014. Most of the Indian mangoes were banned not to be exported to the European countries. Why? Because we did not have a technology to grade the mangoes. Right? I'll come to that little later. Probably I will have 1 or 2 slides ready to it. Plant sciences. As I said, I want to classify a plant to be a medical plant or non-medical plant, right? Very simple problem to begin with. So animal sciences, recognizing animals, senses of animals, tiger senses, sensing how many tigers in Bandipur, right? So we used to, earlier, man used to climb up a tree and sitting over there with a head support and keeping the camera on, observing, and finally making records of how many animals, tigers have crossed from left to right or from right to left, etc. Today, the camera and go after 1 month, automatically a dashboard is created. No video will be given to you so that you sit and watch. No, only output, complete AI-based solutions. So on such and such a day, 3 tigers have crossed from left to right. And next day, the 4 tigers have come from this side to this. So 3 have gone this side, 4 have come this side, right? And so on, like this. So you can also the system calculate the time, difference in time, etc., and so on and so forth. So medical sciences, tremendous. Today in medical sciences, sometimes I make a fun out of it, telling the people that, so when a patient goes to a doctor would recommend for an operation. Then when patient is laid down on a bed, earlier local anesthesia used to be given. Earlier, way back 10 years back, local anesthesia. If some arm has got to be operated, some stomach has got to be operated, only local area within that small vicinity of that anesthesia used to be given. But nowadays, every doctor recommends global, complete body anesthesia. Why? Of course, there is a medical science reason for it, a valid reason for it. Because earlier, if local anesthesia is given to only trunk area, stomach area, and are being operated, the he or she used to concentrate, used to observe it, right? Because the rest of the body components were used to be functioning well and noticeable. But pain was not there, but still she or he used to see it, watch it, right? That was a dangerous situation the people used to face. And because of that, doctors today recommend that better you complete body anesthesia, global anesthesia. But I make a fun out of it. Doctors do not want patient to see, because doctor is not operating, a robo is operating. If a patient understands that a non-living entity is operating a living body, then patient will die, right? So we don't want the patient to understand that only a computer is operating and no human being standing over there. Today, we have gone up to that level. Doctor is not operating. Doctor is simply holding the needle. Needle will go inside along with a raw, along with a saw inside. I mean something which we can cut, scissor inside. So automatically it gets open and starts cutting. And he doesn't operate at all. He will be forced to operate like this by the system itself. There is in the tip of the needle, there is a small camera. The camera will continuously sense the picture inside the body and will be sent, will be sent to the computer. Computer would decide how to move, in what direction this needle has got to be moved. The moment it moved, then scissor starts cutting it. So then segmentation is done, cut is done, and you take it out, extract it. So automatically, that is how the technology is being adopted in medical sciences today. So operations have become more, success rather than failures early, unlike the previous, decade. So harvesting, automated harvesting. I have a land. Let's assume that I have a land of mango trees. I have mango trees about that. Let's assume that 1 acre of land where I have seeded mangoes, and trees started giving the fruits. But unfortunately, I'm not good at identifying what mango to be harvested and which mango should not be harvested and should be kept wait for another 1 week, right? I'm not good at it. Is it a matured mango or not matured? Is it right time to harvest a mango or not? I'm not good at it. But if I can be given a tool, with this camera, I just show, then it has to display, or I just keep the video on and mango tree is being displayed here along with the mango images. Then whatever this matured mango got to be marked here. If I can get those matured mangoes marked here, I can go and pick them up, right? So it's a simple classification of mangoes into ripened or unripened, over-ripened, or after harvesting, post-harvesting. Very interesting. Post-harvesting, very challenging job, right? Because we did not have any such tool which can do automatically the classification, grading of mangoes, good mangoes, bad mangoes, good mangoes, within good mangoes, to be, ripened and unripened, etc. Some classification, right? We also worked on that problem for the last 5 years, and we have come out with quite 2 interesting publications in Elsewhere Science related to grading of mangoes. So vision-based system for grades of crops and so on, right? So there are, look at here, right? There are some in red color, some are green, right? We'll have to classify that, which is good to pick and which is to be, left it for another 1 week and so on. So any such app. So why in food industries, CFTRI is now looking for. Yesterday, last week, I had a meeting with CFTRI scientists where we wanted to launch a new project in collaboration with my research laboratory. CFTRI wanted to have one collaborative. What is that? They want to study the quality of Mysore pak. See, they want to give an app for a customer who wants to buy Mysore pak, so he can go with an Android app. So you go to one bakery and take 1 or 2 pieces of Mysore pak and show it to the camera. Camera will say whether that has been prepared following standard process of making Mysore pak or not. That's our project today. We are trying to launch that with MOU, right? CFTRA has some standard, something like you say ISI standard, no? Similar standard process is defined. Whether all bakeries have followed the same process of minimum standard or not. Can I think of predicting the process being adopted by the bakery looking at the picture of a Mysore pak? Then what do? I take the picture of a Mysore pak and give it as input to the computer. Computer would say, is it prepared by following the minimum standard or not? If not, don't buy it. We are advising the customer, right? So this is what we are trying to explore. And pineapple, yes.
Can I intervene?
Yeah, you can interview. I will give on 10 to 15 minutes for discussion later, please.
Okay, sir.
Okay, make a note of all your points, okay.
Okay, sir.
So look at, so pineapples. So pineapple is so big, and when you cut the pineapple, it is quite normal, quite frequently seen in apples. When you cut an apple, outside apple looks so reddish, very wonderful, attractive. But when you cut the apple, inside you see a soft black, a kind of a tissue, right? You see a soft black colored area inside the pineapple or even apple, mangoes also. When you cut it, you will see inside it is not good to eat, but outside skin looking wonderful. I go to a shopping mall, I buy mangoes of 1 kg, but I get 5 mangoes. When I cut a mango, then only I understand that mango is not in an eatable form. It's not good to eat. If I can notice it in the shopping mall itself, I can avoid buying. That doesn't mean that I can cut the mangoes, all 5 mangoes over there. No, it's a destructive mechanism. So then best thing is to take up a picture. Instead of using conventional camera, you have to go with the X-ray, because ray has to pass through, ray has to penetrate. When I subject a mango for X-ray, I have to put a label. That's the morality. That is the ethic. I got to put a label stating that this mango has been subjected for X-ray. The moment I put a label stating that it has been subjected for X-ray, nobody will buy it. See, these are all the problems. Then recently we just have gone for non-destructive method, but not with the X-ray, but with the NIR scanning. NIR scanning is acceptable for eating purpose, right? For consuming purpose. We recommended two models to grade the quality of the, especially mango fruit, being defected or not being defected internally without cutting it up. That's a wonderful. that we wanted to use for exporting mangoes for European countries. So, I mean, you can think of a conveyor belt, keep the mangoes over here on the basket, let the basket sends one mango at a time. And above that, there is a camera. Camera will scan the picture, right, with the different rays, except X-ray, different rays. And the pictures and signals will be processed. And finally, following classification is done. A given mango, is it ripened mango, unripened? If it is ripened, it goes to one channel. If it is unripened, it goes to another channel. I mean, next to that stage, there is a gate. This gets opened if it is classified to be ripened. This gets opened if it is classified to be unripened. Unripened will go, gets rejected. Ripened mango will go this side. Again, there is another camera after that. That camera decides, is it actually ripened or over ripened? Is it right time to eat it, use it, or is it already over ripened or not? If over ripened, you cannot use it for medical science purposes, creating medicines and all. Then over ripened will go this side. Actual ripened, correctly ripened will go this side. Correct ripened or over ripened? Is it internally defected or not internally defected? Another scanning system. Then finally, it is not internally defected. Internally, it is good to eat and right time to eat, gets pulled into one basket, pack it up and send it. So this is what is called automatic grading. But even human being cannot do it. Even if you hire about hundreds of laborers looking at the mango outside, you cannot decide whether it is internally defected or not. The technology could answer it, right? So there are many such applications, interesting, phenomena, situation. Look at here. In April 2014, especially, European Union banned import of mangoes from India, which resulted in a loss of more than 100 crores of rupees, unfortunately, just because we did not have a sorting system, grading and sorting of mangoes. This is what the picture of a typical system, which I have explained already, right? How do mangoes go and get classified with the support of a machine learning approaches. So AI in animal sciences, health monitoring. Probably looking at your friend, the style with which he walks early in the morning along with you when you go for a walk in the morning. So you used to go along with your good friend every day. One day you notice some change in his walking style. You notice certain changes in facial expression. Then you end up asking, are you comfortable today? I understand that you have some health issues today. Then he says that, yes, I have. How did you notice? If you can notice that on your friend, you can similarly notice such a similar health uncomfortability on dogs that you are taking care of at home, cats that you are taking, oxes, cows that you are taking at home. No, don't you think that? Yes. Similarly, can we use cameras to monitor the health problems of animals? Right? And most of the times we are not there in the field, but many cows and buffaloes are there in the field, right? So then two cows may start fighting each other. One may hit another. Results with that. If that is the case, you cannot be there for 24 hours. You fix up a camera. Let the camera generate an alarm to you so that you can suddenly come over there and control. Or let the camera generate some sound automatically. Laptop can generate a sound so that cow gets disturbed so that they come out of it, not fighting each other, right? I mean, you have to detect the event through camera. Two cows are fighting each other, or suddenly all of a sudden another outside animal will come inside your garden, start fighting against your animal. Then see that your computer will make a big sound so that they get disturbed, they get away, right? So that is what is the advantage of deploying a technology, AI-based solutions for monitoring health and biometrics of animal, tracking of wildlife. Look at here. The face of an animal could be located, detected, and that could be identified, and labels can be generated: chimp, lion, tiger. So you can classify how many animals are crossing my border, what types of animals are crossing my border, right? How many of them are cruel, how many of them are domestic, that you can. Finally, I don't want videos to be displayed in front of me in my office. Instead, for every 1 hour, if I am working for biological related forestry department, I sit in my office, I have a display board in front of me. then every 1 hour there should be a dashboard displaying that and such a junction, so many vehicles have crossed, and while crossing, vehicles have hit the animal, and this animal is being hit, or so many animals have crossed, out of which these are the number of lions, these are the number of tigers, these are the number of chimps, these are the number of sheep, and so on, deers, and so on, right? Every 1 hour, I want statistics to be displayed, not the video. Look at here. One is displaying video, I watch and generate the data. No. Another one is video should be looked at by the computer itself, and computer should be so intelligent in identifying the animals and categorize them into different classes, and statistics should be generated. That should be displayed for me. I have nothing to do with except looking at the data on the dashboard. That's wonderful, AI applications. Look at here, tracking of animals, giraffes, and so on and so forth. So AI in medical sciences, many, right? You have many imaging technology, and because of that imaging technology, the lifespan is expanded of an individual, right? Lifespan of an individual is expanded. So we have many lung cancer, and recently myself and my scholars have worked on a detection of COVID infection in lungs using X-ray technology. We also have published 2 interesting papers just in 2020 November based on COVID infection image examples, right? So image classification. This is quite important, interesting work which we could come out with based on our experience and expertise. Dear friends, I have been in this area of machine intelligence for the last roughly 24 years, guiding students for their PhDs and coming out with some interesting products for demo and so on. So last year when we suddenly come across with COVID-19 situation, so social distance violation was a very important challenging issue for government sector, right? So then we approached the Bangalore police people, because a drone camera cannot be run without a license, right? Even if I have a drone camera, that camera cannot be run without a notice, without a license from police department. So we have taken, myself and my team members have taken license for running the drone camera in Bangalore, and we could capture the drone videos. And when we capture the drone videos, we wanted to identify if there are 2 guys walking together without maintaining the social distance. If that is the case in that area, so that camera used to generate an alarm that there are people violating the social distance. Let me run the video here. Yeah, please look at the right side one. Okay, the vehicles are detected. I think you can see the bounding boxes, rectangular boxes. Vehicles are identified, right? And when people walk in, even that human beings are also identified. This is a solution we proposed. Okay, so look at, there are people walking in, and social distance violation displayed on top. Can you see that? Hope all of you can observe that there is a here on the top, social distance violation, because there were people seen violating the social distance. This is a video captured by drone camera. It's a real-time application I'm talking about, which we have proposed in last year, 2020 June, in month of June, right? During lockdown period, it's a Bangalore city drone, picture. So look at here. I think you can see. Again, drone has come back to the same spot. We launched from here and then it went around and came back. Okay. So this wonderful, application which we have proposed based on AI, artificial intelligence, and then the people were given alert, in case if there were some violence of, or a violation of social distancing. So cough detection, even so if somebody used to cough while walking on the road. So we really worried a lot because of COVID-19. Then how is the cough detection? Can we keep a camera in all streets, and if anybody walks while walking, if somebody coughs, then probably he will be considered to be a COVID-19 infected, then better carry him to the doctor, hospital and get him checked. And that's what cough detection. We also worked on cough detection based on videos. Look at this is another interesting video which we downloaded from internet. Worked on that video. This is not Indian scenario. We got this video downloaded from the internet. Worked on that. It was a conventional video, but on that we used AI algorithms, AI tool to detect if any crowd of people, right? Crowd of people. Let me run that. See, on the top left you say crowd dispersed, crowd dispersed, crowd detected. When it is in red color, crowd detected. I mean, if the camera sees 3 or many people going together, then it displays in red, saying that crowd detected. And if all those 3 people get dispersed, and crowd gets the crowd which was formed, in case got dispersed, then crowd. Look at now, it is no crowd. Okay, here probably you see no crowd. Crowd detected. Look at here, the people going together. Right now dispersed, right? Probably you see here no crowd. I'm sorry. Crowd dispersed, crowd detected, crowd. There are people going together. Crowd detected, right? So here no crowd. There is nothing like a crowd. There is a person walking but alone, right? No crowd. So this is what is AI based tool. I mean, in a marketplace, in another places where you expect many people rushing in but not following COVID-19 guidelines, you can deploy a camera and you just keep a system with the audio speaker. Let the speaker speak out, dear so and so, or if not with a name, hello, you are violating the social distancing. Please don't make crowd. It's otherwise very dangerous. You can advise as if there is a policeman standing and watching and advising the people not to make any crowd, right? So this is another interesting phenomena or a scenario which we worked on. Similarly, we had worked on attendance of employees in retail shop, entry gate. Okay, who will come to my office? So it should be monitored, and who are the royal customers to my office. All of a sudden, look, it happens that Vice Chancellor of University of Mysore will rush into my office unknowingly, but I am still seated in my office. But it's a protocol of that, when Vice Chancellor takes a step into my department, I, being a chairperson of the department, should go to the front gate and receive him. So then, if there is a camera in nearby the front gate of the camera can sense it and understand that Vice Chancellor is coming to the department. So camera should send me a signal stating that Dr. Guru, you are inside. Please come out. Vice Chancellor is coming into your department. Then suddenly I can come out. As if there is an attendant standing near the main gate, and having seen Vice Chancellor coming into my department, he will suddenly run through the corridor and comes to me telling me that, sir, VC sir is coming. Then I go suddenly. Instead of that, can we have a AI-based solutions? This is very simple applications, right? Okay. So you are all attending my lecture on the other end. I understand. I assume that you are all attending. And you're all alert, you're all so alert and listening my lecture. Who knows? You must have kept your audio muted, video also muted, and started sleeping. Or you must have kept yourself, signed in, but you must have gone out of your residence for some shopping purpose, buying vegetables. Who knows? Can I think of an app, AI-based app, which could be run in your specific computer? The moment you logged in, automatically it runs on your computer. And for every one of you, if you are 36, there are 36 instances running in parallel on your respective systems with camera on. In case if you are going out of the visibility of the camera starts noting that at what time, 10 o'clock, 10 minutes, 10:10 he went off. Then you came back after 30 minutes, 10:40 he came back. That should be recorded. And while though you are physically there, but may not be concentrating on my lecture, looking at other side, looking at this side, then camera has to understand, oh, you're not listening Guru Sir's lecture. What time? Then you become alert suddenly. Then when did you become alert? At what, till what time you are alert? If that could be automatically generated, I don't want those sensed captured videos to be transmitted to the HRDC of Mysore. Instead, I want only the data generated out of watching you, should be sent across the network to Dr. Nanjut Swami, so that Nanjut Swami looks at the record on every individual and finally make a note of your alertness. Can I think of AI? That is what is really challenging. We are thinking of providing AI-based solutions for maintaining attendance of students in our online lectures, because you are insisted to take up online classes. I'm still, you are facing the same difficulty that most of the students are not that alert, and you are not sure that whether they are really listening you or not, and even you are not sure that whether they are really physically present in front of the system or not. So can we think of AI-based solution to monitor the progress, to monitor the alertness, to monitor the attendance of students in online lectures? So we are working towards that, and then I'm thinking of submitting a project proposal for DST, which is planned for 8 months. If DST gives us a good grant, as we mentioned, probably down the line in next 8 months, we can think of delivering a product which can be deployed all along with Zoom application or along with Google, Meet. So with respect to respective computers of an individual who are participating in the online discussion. So this is activity detection. Look at the first picture. You would say that somebody is entering the office. Okay, glass door. There are vehicles parked outside. So this person is entering the shop. But then look at the second one. The people are exiting the shop. Right? How do I differentiate these two activities? Very challenging for us, right? How do I? And there is a person on the on the what do you call it as football. There is a person, a boy walking on the football, but still visible for the camera because of the glass door. Then camera should not understand that he is inside. It has to understand that he is outside. Then how do I classify the pictures of the people separated by glass as inside and outside, because both look same? That is quite challenging activity detection with AI. So look at here. So probably if you are familiar with me and my body and my appearance, probably you will notice that the person who is standing on the right side, keeping hands on the body, is myself, watching these people playing sports. So this is, we intentionally created for sports applications, AI in sports, right? Please observe carefully. Look at, yes, and that fall has been detected, and crowd is formed. Look at the top left. You see crowd is detected. Somebody has fallen, right? So there was a camera, surveillance camera. We captured this video through the surveillance camera. We wanted to build up an AI system to identify if somebody falls down during playing shuttle badminton. If that is the case, he may meet with injuries. Then we should call suddenly an ambulance and so on. Automation of that. So that's what we worked on this issue. This is another. You can, let me see. The same thing, I think. This is somebody who is disturbing people while playing. See that myself is disturbing others not to play. That event should be detected. So, and similarly, sometimes it happens that when you understand that you are under surveillance of camera, then before you do something of your interest illegal, you better close the camera. Sometimes people do that, no? You close the camera, you hide the camera, and do whatever the activity you want here. So even when you obscure the camera, then camera has to generate signal automatically, understand that somebody is trying to hide me. Camera becomes so intelligent. It's not that camera is monitoring somebody. Camera has to monitor itself first, right? So that's what is the application of this video we built up. So this is into civil engineering, especially in construction area. The people are expected to wear a helmet and safety jacket, right? But sometimes laborers will work without helmet, without safety jacket. So during construction area, anything may happen, anything may hit the head. So safety guards are mandatory. But sometimes laborers are not that, focused. They are very, negligent. Because of negligency, they may not have a helmet. If somebody has no helmet, then there must be some Mestri person who has to watch continuously. Unfortunately, Mestri cannot stand there for 24 hours. Then why can't we fix up a camera and let the camera understand that? And finally, tell the man without helmet or whoever wants to remove the helmet. So while removing the helmet, it has to generate the alert signal telling that so and so, please don't remove the helmet. Wearing helmet is a must. Otherwise, you walk out of the construction area, do whatever you want. That instruction should be given as if there is a supervisor in the construction area, right? So here is something red, on the right side you see here is something red rectangle is drawn. This is called a dangerous location. This dangerous location, nobody is expected to enter. If anybody steps in over here, then alarm should be generated. So this is what is the video where we deployed such a tool. Notice somebody is trying to go through it. Suddenly he is marked. That man is identified. Look at the people are detected. And whenever such a detection happens, the signal alarm will be generated. Okay, alarm will be generated, telling that you are into a dangerous zone. Quickly pass out, quickly come out of it, and so on, right? This is about yeah, 30 minutes, 30 seconds video. Sorry. See now, it gets detected. See. So these are some applications of AI based technology or AI based solutions for our day-to-day life activities. Right? Look at this is quite interesting video. I want you to carefully observe this video, please. Let me not explain you. It's about 30 seconds video. Please watch it. This is also a video captured in real time. Whatever the video you are now seeing or you have seen so far are the real time videos happened, right? Not created. These are the videos captured in real time, worked on them. And see, especially you notice here at this, there is a blue colored, dressed person climbing up. Watch that portion, please. Unfortunate, that's not a robot. He's an individual. He's a human being. Fell down, got injured. What is the purpose of AI then? The purpose of AI is not to detect that somebody has fell down after after he is injured. No. I want camera to monitor that while the person was climbing up the ladder and instructing him, be careful, as if there is an engineer watching person climbing up while he himself watched that person climbing up, holding some bucket in the left hand and holding only one hand, with the support of one hand. You must have instructed him, be careful, be careful, be careful. Similar messages, instructions are going to be continuously generated. So and so, be careful. You are trying to climb up with the support of only one hand. You may slip down. You may slip down. Please be careful. If that messages are given by identifying the activity of what? A man climbing up a ladder. That's more important. If a camera is so intelligent in identifying an activity of a man climbing up a ladder, suddenly those instructions can be repetitively generated, right? Okay. So this is one application. Another application, let's assume that there are no other people, only one man is working. Even after falling down, even he got injured after injured because he is totally injured, heavily injured. He cannot move, he cannot cry, he cannot make any sound. He is so silent, maybe unconscious, but nobody is there to look after. Then the person or the owner of this or engineer of this construction area may go next day. By the time he will die. If there is a camera setup which can monitor the activity that somebody has fallen down, then suddenly the system can send a signal, can send some text message to the respective engineer SMS, right? Or suddenly it may ring up the telephone also. You can linking it up. Suddenly the camera can ring up the telephone of mine, telling me that, Dr. Guru, look in your construction area, some labor has fallen down. You go there and attend, otherwise you will die. So that I can take care of. Look at, we find tremendous advantages of exploiting the beauty of AI-based solutions for day-to-day life activity. Look at, this is a traffic. You must have heard of traffic in Bangalore. This is a very less traffic, strictly speaking, as well as my experience in Bangalore is considered. This is one two-way, but one direction, no, almost nil traffic, but another direction, there is a heavy traffic. This is a morning traffic, around 8:15 in the morning, right? So one way means people are moving out of city towards working areas, working regions, industry areas. From nobody is moving from industry area back to city. This is a morning, but in the evening it is reversed. Okay, so heavy this is moderate traffic I had seen, but around 9 o'clock or 9:30 in the morning, vehicles are almost nil motion, almost nil motion, right? Okay, look at, this is what was our project. The project is to recognize the number plate of every vehicle in this traffic. And look at, on the right side here there is a track. Here this area is restricted only or reserved only for heavy vehicle like buses and lorries, not for two-wheeler, not for cars. Then police people wanted an AI-based solution to recognize the number plate of all those vehicles which are not supposed to pass through this track. After this, cars and two-wheelers can ride, but this track is only for public buses, public transportation, right? So if there is a bus, no issue. If there is a two-wheeler, there is an auto rickshaw, there is a car here passing through here, then automatically the system has to recognize the numbers, and those violating cars or vehicle numbers should be given to the police people so that they can issue a notice. So then recognition of number plates. Look at, this is a traffic. See, there is a car behind a bus violating the rule. There are many cars behind the second bus violating the rule. Two-wheelers are violating. The issue is to identify the number plates. The issue is to identify the number plates in this heavy traffic. Okay. This is about 47-second video. This is a raw video which we captured physically standing on the bridge across the road. Look at, here is a solution. Here is a solution. Probably you see a number recognized here, displayed. Number recognized here, displayed. This is a number plate identified. This is the text equivalently displayed. Numbers have been automatically recognized. Okay, you can see something in white, right? That's what is 4995, right? This is the number recognized of this vehicle, Innova. Okay. See, here is in white, the number plate, number of this. Even our vision system cannot recognize, but computer camera could recognize these numbers. Look at here, displayed in white color. The traffic automation, the police people wanted this project, right? This is another not Indian scenario, outside India, especially in Singapore. A Singapore customer, where here is actually what you see, what is this called, gates, two pairs of gates are here. To the right of this, there is actually airport. You can see an aeroplane here, right? So this is completely restricted domain, restricted area, and these are the gates where trucks are allowed to pass through. I mean, the trucks carrying goods can enter either through the gate number 1 or to the gate number 2. So then the question or the problem was to identify what are all the trucks passing through gate 1, passing through gate 2. By the end of a day, how many trucks went through gate 1, how many trucks went through gate 2. Not only by the end of a day, every 1 hour, how many trucks were gone through this. by 10 o'clock in the morning, by 11 o'clock in the morning, 10 to 11, how many trucks went through in the gate 1, gate 2. So, and then at a given time instant about 10:30, how many trucks were on the in the queue, standing in the queue, because here security guard has to give a permission for the driver to drive the truck inside, right? He has to seek a permission. The authentication should take place. How long does it take place? For what truck? Authentication process was a longer time. Why? These are all the reasons. Then there was a camera kept here outside capturing the video signal, and the trucks were passing through, and calculating the queue length, how many trucks were there in a queue at a given instant of time. What is the waiting time of each truck? Dwell time of a truck, dwell time of a truck. So this is, I mean, video should not be transmitted across the network. Only the generated data out of this video should be. I mean, look at generating the data is inferencing, video processing, and creating the tabular representation and displaying on the dashboard is a artificial intelligence. So let me, I think I have a video. This itself is a video, I believe. Let me run it. See, and these roads are with multi lanes, and I am not concentrating on all trucks passing through any lane. I'm supposed to look at only the trucks passing through that particular lane, which directs the truck to pass through these gates. These are the identification of the truck, and truck will be given a unique ID, and sometimes this camera will miss the information of the truck. Again, same truck gets recognized. Look at, even though there is a truck passing through in adjacent lane, look at, here is a truck which passes through this lane, and that should not be detected because it is not passing through the gate. Here the problems are many, in fact, challenging problems are many, right? And look at, here is a very used truck, red in color, which passes through here adjacent lane itself, but that doesn't get detected, should not get detected, because it is not entering into the airport. Only these trucks which are waiting. This is also a truck waiting. Maybe it may be waiting either because of trucks are waiting here, or because of this traffic signal is not permitting, right? Anything may be true, but not necessarily to be considered for waiting here, unless you are sure. How to classify, how to recognize only those trucks which are passing through this lane. This is quite interesting, challenging, even for computer scientists. But I want you to understand, where is the AI here? What is the significance of AI? While teaching your students, you can tell them that, if you have some knowledge of this AI, at least if you are BA in economics and history, if you have some skill of using these videos and creating your own application by the use of tools, and if you take up that skill development, probably you will have one and some handful of job. You will be a very hot person in AI industries and so on and so forth, where you can use your economics knowledge and so on and so forth. So this is one application. Finally, what we wanted, actually, we wanted this. Here. Look at the top. Bottom left corner. There is a table. This is what I want to be displayed in my office, not the video in my office. Okay, in my office, I want that to be displayed. So this is what I want. Dwell time calculation of vehicles shown in video. So it says that total number of vehicles exited is 4, total number of vehicles currently in scene 2, right? And so on. And for every vehicle, how many different numbers have been generated, what numbers are equivalent to which numbers, generate the equivalence class, and then calculate the time difference, say what is the waiting time of each vehicle. This is what is expected to be finally displayed on the dashboard of a top lead officer of the concerned airport. Okay, so there are we also worked on some civil engineering related applications. So in Mysore city, real estate is tremendous business of real estate, and in most of the extended areas, many houses are being constructed, many buildings are being constructed. While before constructing, we go for digging out muds from the earth. So we take out the muds. Then when we take the soil out of it, the same soil is used for foundation, right? Is that the soil reserved for only foundation purpose, or can it be used for agriculture purpose? If that soil appears to be more fertilized land, so that soil can be used for agriculture purpose, why can't I export this for the agriculture purpose and bring some non-agricultural soil for foundation purpose, right? That's what we just have started working on good earth quality, calculating, estimating the goodness of the quality of the mud, quality of the sand, soil, classification of soil into multi-classes, and so on and so forth. This is into civil engineering. This is what the system and the schedule which I proposed for DST for a project. So equipment and vessel detection in a huge construction area of Manasa Gangotri campus. There are about 700 cameras. Let's assume that there are about 100 cameras deployed. Then construction activities being taken place. And sometimes one of the vessel is kept in one corner of the campus, but not being used for 1 week, and nobody has noticed it. Can camera identify such vessels, such equipment, such vehicles which are just parked, but people have forgotten? So that it can instruct that there is a vehicle, right? There is a vehicle which is parked 2 days back, but not being used. Why don't you make use of that vehicle? Otherwise, you just leave it back because you have brought it for rented purpose. So there are certain vessels, equipment which are parked in the construction area, not being used, but are rented. Why? You just give it back. You can give advice, right? That's a camera for monitoring purpose and so on. There are many such applications, dear colleagues. So sign language understanding, we are automated and we produce 3 PhDs. I mean, I just sign, deaf and dumb people sign, but we don't understand. I speak, he doesn't understand. I'm not good at producing the sign. He is not good at speaking. Then can we think of a system? Then what do? I talk in front of a mobile. I talk in front of a mobile camera. The mobile camera will produce the sign for a deaf and dumb people. They look at the monitor, understand what I am talking, and they sign in front of the camera. The camera will capture the sign being produced by that physically challenging people, and then convert it to equivalent English and speak out. This can be used as a translator, right? So driverless car, we are talking about. One of my PhD students has been put on this project of driverless car in USA in one of the reputed companies. News categorization, automation of attendance, smart television. Look at television is to watch, but no. Down the line, you will have another 18 months perhaps. Samsung industry will come out with a smart television which will watch you watching television. Right? Television, automatic control of television. While watching television, if suddenly my friend comes into my residence, then suddenly I change my alert and then talk to him. The television is watching me, understanding that I am watching the television, and suddenly I got myself deviated towards my friend. My friend as activity gets detected. Friend has appeared, guru has got his attention deviated. He is not looking at me. Having understood that the television, that guru is not looking at me, automatically it goes to a sleep mode. The moment I attended my good friend and then send him out, and then I changed my direction of looking at it. The moment I started looking at the television should start displaying the same channel. Or by the time if that event is over, I mean that serial or anything, the program is over, probably it is by 6 p.m. Generally, guru watches another channel at 6 p.m. The television should understand my requirement, switch over the channel. This is what is called smart television, digital library. There are many interesting applications of it, dear friends. Before I terminate my lecture, I always say that the facilities are available in my laboratory. I have a lab called Data Analytics and Learning Lab, which has produced roughly about 82 PhDs related to this so far for the last 20 years, right? So we have been working on these related AI-related projects for the last roughly 24 years. So as and when time permits, in case if you happen to be in Manasa Gangotri campus, please don't forget to make a step into my laboratory and see what our people are working on for automation of most of our day-to-day life activities, not to replace a human being, but to supplement his activities so that it becomes more effective and efficient. With all this, our world is changing. That's what we have observed. From evolution period, millions of years to thousands of years to hundreds of years. So from evolution to civilization to science, and then technology makes change every minute. Drastic change. World is changing. That is the only permanent thing in the world. We are not permanent. No building is permanent. Change is the only permanent. We are going to get along with the change. we are going to adopt the technology today, right? Otherwise, we are nowhere in any of our area of interest. So world is changing. Changing is the only permanent. Look at that was the first aeroplane invented by brothers, whereas the bottom one is the smart aeroplane today. Smartness, science is not responsible. Same science. Engineering is responsible. Same engineering, but only the technology makes the difference. Technology has made it beautiful. Technology has made it smart, not the engineering. Engineering made it a product. Science created it. Science created it. Engineering made it a product, but small, technology made it a smart, right? Brahma created me in my body, physical skeleton, right? Engineered product of by Brahma, but my handsomeness is the technology today. Look at that was the first steam engine. This is a bullet train, but the principles are same. Science is same, engineering is same, but the technology differs. So this is what vulcanization of rubbers and its applications, right? Earlier telephone, Graham Bell, now iPhones, very smartphones today. That technology, nanotechnology matters a lot. Everything becomes very small component, right? Carrying is very simple, appearing wise very smart. So smart televisions, right? So these are smart. Everything is smart except human being today. That's what I'm saying indirectly, right? Human being makes everything smart by giving away his smartness. Okay, mobile library. You walk with a pen drive. Pen drive is a library. You need not go to physical library today. That's what we are talking about, right? So this is the earlier camera, and this is a smart camera today. That was a moving object detection camera invented by brothers, but this is what is a new smart camera. Friends, we should now look at this picture where monk have become a human being. Again, human being in front of the computer has become a monkey-like personality. I'm sitting like this. I'm almost now going back to monkey physically. And day by day, my mental stress, because of stressness, my intellectual ability is also going out. I am programming, end up programming. And who is happy today? Robo is happy today. Robo started coming in. So evolution comes up and then gone down, it seems. So the new evolution of man should not end up with the evolution of man. I should continue towards evolution of robo. I mean, in future, we should not speak on evolution of man, but we should speak on evolution of robo, intelligent systems. Even in robo, there is first level, second level, third level, and intelligent. Every robo is becoming more smarter and smarter. That's the history. Evolution of robo should be the content of school textbooks rather than evolution of man, Darwin's theory today. So that's how we are going to educate our next generation, right? So that they become more contributors, more efficient, and more productive. So if I sum up my lecture, friends, I think it's 1 o'clock now. So in summary, I say intelligent computing. I presented about empirical paradigm of science, theoretical paradigm of science, then computational paradigm of science. I would say today, the fourth paradigm of science is called data science. Okay, so data paradigm of science. So applications I've narrated. I am sure that the applications of AI with a couple of interesting deployed, videos which I shown. They were the real solutions deployed working, right? Okay, so because of efforts put in by my great research scholars, so we could deploy a couple of product also in working environment. So with this, thank you all. Thank you very much. And you are having 5 to 10 minutes for discussion. Please, you can raise questions and let's have interactions if any.